Okay, so the first thing we're going to go over, answering questions for people in class, is absolute value inequalities. So when we have an absolute value inequality, making up anything here, you're obviously going to have an absolute value situation. So here I have two absolute value bars. Ooh, this is very dark. No, let me just my computer screen there. Is that brighten on that end? Yeah. All right, I have my absolute value bars. Now I have to write an expression in here. So let's say I have something like 2x minus 5. Let's throw a coefficient out here. Maybe I have 3. Let's do minus 14. Minus 14. And I'm going to have my inequality. Let's say I have greater than or equal to 11. Okay, I want to solve for x. It's an absolute value inequality. I didn't write down directions here. Okay? I'm going to go ahead and isolate the x value. What should I do first to get x alone, Daniela?
Add 14.
We're going to add 14. So we have 3. Absolute value of 2x minus 5. If I add the 14 over, on this side I have 25. Next step. Now, could you have divided everything by 3 first? You could have, but I feel like people make a mess. You'll have 14 thirds, 11 thirds. It gets a little messy. What can I do next? Go ahead, Tatiana. Yeah, divide both sides by 3, so divide 25 by 3. Really, we're dividing the 3 out over here as well. Our goal, why did we do any of this stuff? What are we trying to get alone? We're trying to get the, right, isolate the absolute value. Exactly. Now we're here. Stop taking time to turn these into decimals or mixed numbers. You're going to leave this at this step like the way it is, but we're not done. We're really down to like phase 1 accomplished. Now, from here, we have to move on to phase 2. Phase 2 is where we're going to set up our work to solve that has no absolute value bars. There's no inverse operation for absolute value. It's like to get rid of a square, you take a square root. To get rid of multiply, you divide. To get rid of minus, you do plus, right? There's no inverse operation to unabsolute value something. We do it conceptually. The absolute value would make this positive. Whatever's in here needs to end up being greater than or equal to 25 thirds. Okay, first and foremost, whatever's inside, which is that, has to be bigger than or equal to 25 thirds. Cool. However, I'm going to make it positive anyway. So I also need to account for the fact that whatever is in here could also be less than or equal to negative 25 thirds. Exactly. Because you're going to make it positive. What's less than negative 25 thirds? Negative 26 thirds. What if I make negative 26 thirds positive? Now it's 26 thirds. Is it bigger than 25 thirds? Yes. So you set up your two inequalities. What are they? Structurally, you have the inside, I'm going to call it inside, untouched. You don't change a minus sign to a plus sign. I never did that. I do not change that. Inside, same inequality, same number. Inside, which is this, same inequality, same number. And then the other one is, we still have the inside, but you change the inequality and you change the number, okay? That's the setup. I said that right from the beginning of the year when we did examples on this. So same thing is still true. Now, we just don't have a meltdown over our fractions and all is good. So I'm rewriting 2x minus 5 greater than or equal to 25 thirds. Now, if you hate fractions, I hope you don't because I think fractions are lovely. But if you hate them, you can get rid of them and save it for the last step. I'm going to multiply everything to get rid of the fraction, just to show an example of how to clear it out. What can I multiply everything in this example by to get rid of the fraction, Taya? 3 times 3. What do I get? 6x minus 15 is, think smarter, not harder. Do not tell me 75 over 3. What happens? They reduce to 1. You're only left with 25. Now, you'll only have to deal with the fraction in the very last step. You don't need common denominators. You just cut that step out of the work. Add 25, I'm sorry, not 25. Add 15 to both sides, right? I'm not cut off, right? I'm still on the screen. I'm just going to scroll up a bit. I get 6x is greater than or equal to 40. Divide by. So x is greater than or equal to, divide by 6. 40 over 6, divide by at least 2, right? They're both even. So that's 20 over 3. Now the other side. I'm not going to clear out the fractions on this side, just to compare and contrast. So here I have 2x minus 5, just rewriting it, less than or equal to negative 25 thirds. If I add 5 to the other side, because I'm trying to get x alone, I'm not going to write plus 5. Instead, I'm going to write plus something over 3. What over 3 is equal to 5, Reuven? 15. So I'm going to write that instead. Some of us do genuinely need work adding and subtracting your positives and negatives. Okay? So when I share those like quizzes with you with like fundamentals like positives and negatives, adding and subtracting, believe me, I'm not doing it for just to boost grades. It's because people need to work on it. Okay? So negative 25 plus 15. What does that get me? Negative 25 plus 15 is negative 10 over 3. Then here, When you divide by 2, here's another big issue people are running into. You guys are doing divide by 2 over here, oh boy, and you are making up your own rules about mathematics. So, yes, this is fine, it goes away. X is less than or equal to. Okay, it matters. It makes a difference if it's 10 thirds over 2, or if it's negative 10 over 3 halves, or if it's whatever, I don't even know what way to say it. But instead of doing divide by 2, I strongly suggest dividing by 2 is the same as finding what of something? Or the word half, right? Literally half of something. So it's literally the same as finding half of something. So the word of means multiply. By doing it this way, you will less likely screw up where you stick this 2, because you guys are putting it in all the wrong places. What should it end up being now? Again, think smarter, not harder. I'm going to reduce. These reduce. 10 and 2 become? 5 and 1. Good. So that's negative 5 over 3. So now, this, well, really, I guess it's this number. I'm going to cross that out. Reduce. And this, those are my 2 inequalities. I never graphed them on 2 different number lines. Why are you doing that? I don't know. Okay? So I never showed you that. Don't do that. Here's my number line. This is all one problem. The solution goes on one number line. You guys need to know the difference between size when it's fractions. Which is, if they were not negative, which is bigger, 5 thirds or 20 thirds?
5.
If they were not negative, 5 thirds or 20 thirds, you're saying 5 thirds is bigger? Even if they were both positive. Listen, hear me out, guys. Even if they're both positive, 5 thirds is still smaller than 20 thirds. Pretend that this is a third, this doggo. See him? Here, this is a third. I have 5 thirds, so that means I have 5 of these doggos. Got it? But if I have 20 thirds, I have 20 of them. I don't know. What is this guy? A French bulldog?
Yes. Yes.
Little guy. Handsome guy. Okay, beautiful. So thirds, think of it as a unit. Put your feet down. Thirds as a unit. So you have 20 thirds versus 5 thirds. I know, but positives and negatives aside, some of you guys are putting things in your number line in the wrong order. This is alarming because those are things you should be getting right. That shouldn't be messing you up, okay? But negative, obviously smaller. Now, greater than or equal to 20 thirds. Here's 20 thirds. Here's negative 5 thirds. X is less than or equal to negative 5 thirds. X is greater than or equal to 20 thirds. Or equal to, colored in? Yes, color it in because it could equal it. Greater than or equal to this goes that way. Less than or equal goes that way, okay? Now we're there. How do I write this? Using the whole point, guys, of doing the inequalities is interval notation. It's not to shade on a number line. That's not the point. The point is interval notation, so we can use it on domain and range and algebra. Do not submit answers that are just this and this. I need interval notation. Everything that's pink is a solution. I need to describe this set, these intervals, 2 separate ones. So Paige, how could I write my answer?
Negative infinity, comma, negative 5 over 3, bracket.
Good, we're gonna use a bracket, and this was a parenthesis infinity. Always gets that, good.
Union, bracket, 20 over 3, comma, infinity.
Beautiful, okay? Beautiful, we're good? So that's it, that's the end of it, okay? So really, if the directions ask for interval notation, even if it doesn't, if it doesn't ask for it, still, it should be good practice. At this point, it should be second nature. Put it, okay? You should be putting down interval notation. Okay, so now we're going to talk about finding the domain of functions from their equations instead of just finding domain from a picture, instead of finding a domain from a mapping diagram or a table of values or a set of ordered pairs. So we had, in a review packet, we had a whole bunch of different examples of domain, of functions or relations. It looks something like this, right? So we had a graph that might look like this or this. We had table of values. We had mapping diagrams. We had sets of ordered pairs. But what gets challenging for people are 2 cases. One, finding domain from equations and finding domain from graphs, okay? Those are the harder problem areas. These are a little bit easier, right? A little easier this way and a little easier that way. These are a little bit harder when you have to deal with the equation. So associating different equations with their pictures is going to be really helpful. So that's one thing. But there's 2 rules that are really going to help us out along the way. One rule is we are not allowed to divide by what number? Good. Divide by 0. Big, big rule in math, right? We're not allowed to divide by 0. So whenever you have division by 0, so I could say 27 divided by 0 equals undefined. Okay? Or if you go into your calculator and you type in, 32 divided by 0, your calculator might say error. Or it even sometimes says, say, 64 divided by 0. It might even say domain error. It actually uses the word domain. Division doesn't always look like that cute little division sign, right? What other ways do we divide? There's long division, right? So I could have 25 divided by 0. That's still bad. We can't do it. What else does division look like, though? Major way we can describe division in math class, Reuven? A fraction, exactly. So 0 essentially is not allowed in the denominator, okay? So if you have a number on top over 0, that's not allowed. 0 on top, 0 on bottom. 0 on top, that's okay. It equals 0. 0 on bottom, no, that's undefined. Okay? So that's one of the two rules that we're going to highlight right now. The other major rule, number 2, we are not able to get a real solution when taking the blank of a blank. I'm not able to get a real solution when taking the square root of a negative number. Now, always try to flip it, reverse it, whatever. Negative numbers are bad for being under our radical. Then what kind of numbers are good? And be careful when you answer. Negative numbers are bad, but what kind of numbers then are good? Paige? Positive numbers. Okay? Integers would mean it's just like 1, 2, 3, but like 1.5 is good, you know? Positive, what else are we leaving out? All we're trying to exclude is negative, so 0. Good. That's what we said, Gus? Good. 0. So 0 is also fine. We can take the square root of 0. So these major rules dictate our domains. Okay? So I have a few examples for us to kind of look at, right? Here. Find the domain of each function. So number 1, f of x. I'm going to make up a linear function. Can someone make up a linear function for me? What would a linear function look like? X plus 2. Fine. X plus 2. You know it's linear because x is to what power? Not none. 1 first. Exactly. That's a 1. Really, this x over here, this is x to the 1. This is an invisible, a little x to the 0. X to the 0 equals 1, so we don't write it. 1 times 2 is still 2. And then x to the 1, we don't write the 1, we just leave it. That's linear. Now, you've dealt with linear equations for a long time. You dealt with them in pre-calc. You dealt with them in pre-algebra. You dealt with them in algebra 1. We've been dealing with linear equations for a long time. So when you see a linear equation, I want you to not only see its equation, I also want you to think about its graph. What does the graph of x plus 2 look like? I mean, you should have a pretty good understanding of what the graph looks like, right? What can you describe in this equation, Callie?
So, like, the y-intercept would be a positive 2.
Good, that's right here.
So, and then it would just be like increasing by 1.
The slope is?
The slope is 1.
So up 1 over 1, up 1 over 1, and we get this linear equation.
Yeah.
Now, you guys have gotten better at finding domain from a picture. Every linear equation, think about it. It's either going to look like that, maybe it looks like this, maybe it's a horizontal line. If it's a function, it will not be a vertical line, right? Because that would fail the vertical line test, so we don't have to worry about those. What do all of these domains have in common? What's the domain of a linear function? Nadav? All real numbers. So the domain, using interval notation, is going to be from? Exactly. Every linear function will have that domain. Done. Conclusion made. Every linear function, if you can recognize, and that's why I said you don't need to name it, but I need you to recognize a linear function. Every linear function, the domain is going to be negative infinity to infinity. Done. Mathematically, there's no rule I have to worry about. Nowhere in this will I ever have to worry about dividing by 0 or taking the square root of a negative. X is fine where it is. I'm just going to have to add 2 to my x value. I could add 2 to any number. It's fine. So we're good. Any linear function, do you have to think about it? No. You're just going to recognize it's linear, and you're going to tell yourself, all right, it's linear, so the domain is negative infinity to infinity. Done. Okay? Next, quadratic. Make up a quadratic for me. What would a quadratic equation look like? Quadratic equation. What does it have in it? What's the identifying feature? Go ahead, Reuven. Good. Sure. As long as it has that x squared, it's quadratic. Now, again, quadratics, we derived some quadratic parent function for us. We derived, and we talked about x squared. And then we remembered that you dealt with x squared in algebra 1. What does the graph of x squared look like? Or what's the name of the graph, Ezekiel? Parabola. So we know it has this look to it, right? Now, what can happen to the parabola? The 2, we're going to learn, all it really does is it might make it look skinnier. These numbers might just shift where my vertex is. If it were negative out front, do you remember what happens when there's a negative in front? I see hand motions. Yes, it's going to flip over. It'll be opening in this direction. But when I'm asked to find the domain of a quadratic function, are these getting wider forever and ever and ever? Are there any holes? Are there any asymptotes? Are there any breaks? What's the domain for every parabola? The domain for every quadratic function, again, is going to be, again, all real numbers, negative infinity to infinity. You're good. Okay? So the domain of every quadratic function. Do you have to worry about dividing by 0? No. Is x anywhere in the denominator? No. X is a wild card. It's a variable. I don't know what you're going to plug in. So you just want to be aware of the fact that you don't set x up in a place where you can plug in and get undefined. Nothing will create an undefined situation here. That means my domain, my values of x that are permitted for the equation is everything. Any number is permitted. I can plug anything in to that equation and get an answer, and I will be hunky-dory. Everything's great. Next, any other polynomial? Question? Oh, okay, so another polynomial of degree bigger than 3. It's going to have the same look, but my powers can grow. So, Cal, you made one up. Go ahead.
So 3x cubed minus 4x squared plus 2x plus 1.
Sure, beautiful. Any polynomial, I don't care if this is a 31 and a 20 and a 14th power, okay? It doesn't matter. Do I have any x floating around in my denominator? Do I have any square root symbol with an x in it? No. This is still a polynomial. As your polynomials grow, I'm going to show you a little thing here. X to the 3rd power might look something like this. I don't need you to know this right now, I'm just showing you. X to the 4th power might look like this. X to the 5th power might look like this. X to the 6th power might look like this. Do you see what happens as the power gets bigger? There's just more bends in the graph. X to the 1st power, how many x-intercepts does it have? 1. How many x-intercepts can a parabola have? 2. How many x-intercepts can a 3rd degree equation have? 3. That's really what's going to be in a later unit. We're going to learn about that. But these arrows again at the end, and they might be a little simple, less bendy, but these arrows at the end, does it get wider forever and ever? Yes. Are there any breaks in it? Any asymptotes, holes, any reason that you can't plug an x value in? No, right? There's no bad x value. So what's the domain going to be for any polynomial? Take a wild guess. All real numbers from negative infinity to infinity. Boom. So how much brain power are those questions going to take? About like 1% brain power. Okay? That's all you need. Now, here's the wild ones, okay? A rational. By rational, I'm really highlighting the phrase ratio. And by ratio, you should be thinking of a fraction, exactly. So if I have a rational expression, I'm going to take this x plus 2. I'm going to put that in my denominator. And I'm going to have another thing up here, maybe this thing, right? 2x squared plus 7x minus 4. It really doesn't matter. The numerator, I have no problems. Any number can be in my numerator. 0, a negative, 12, pi, who cares? Any number can go up here. This is not an area for concern. But here, denominator is what you are blanking by, dividing by. I'm not allowed to divide by what number? 0. Does that mean that x cannot equal 0? If I plug in 0 for x, I get 0 plus 2. So it's like I'm standing at the gate and I'm like, I'm supposed to be blocking anybody, to come into the event that might have, noisemakers because you're not allowed to make noise in the audience for this thing. But I'm waiting for a noisemaker to come walking in. If I don't have a noisemaker with legs, I'm not going to stop them at the door. Well, what if they're going to make a noisemaker or carry a noisemaker? Reuven comes in with water bottles and beads in 2 separate bags. He didn't make his noisemaker yet, like a shaker to make noise in the audience. He has the ingredients to make one. He's going to make it once he gets in the bleachers. I need to stop him at the gate. That could cause for a noisemaker. 0 is not the problem. 0 plus 2 is fine. I divide by 2. What number is bad, Tatiana? Negative 2. Now, here's the issue, is a lot of you guys are like, what plus 2 will give me 0? And sometimes these get to be annoying, like you have 13x plus 20. Okay, if you have 13x plus 20, what times 13 plus 20 gives you 0? Please don't ask yourself that question. There's this thing invented, it's called algebra, and we're going to use it to find out the number. So, the bottom, do we all agree you're not allowed to divide by 0, right?
Yeah.
The denominator is what you divide by, true?
Yeah.
Agree? Okay, that means the rule is essentially the denominator, whatever is in the denominator, is not allowed to equal 0. And then we're going to solve for x, but instead of solving for what x does equal, you're essentially finding out what x doesn't equal, what it can't equal. So 13x plus 20 doesn't equal 0. Subtract 20, 13x doesn't equal negative 20. Divide by 13, x doesn't equal negative 20 over 13. So your j of x, your parents tell you, you cannot hang out with that negative 20 over 13. That's a bad kid. And you're going to say, well, who can I hang out with? And your parents are like, literally anyone else. I don't care. Just not hanging out with negative 20 over 13. They're a bad kid. They shoplift. Okay, I don't know. Whatever their issue is. You're not allowed to hang out with them. Who can you hang out with? Nobody. No, you can hang out with except that. Right. So I'm going to look at it on a number line. Here's negative 20 over 13. Not allowed to hang out with that number. Right? Bad news bears. That number is off the list. Who can you hang out with? Everyone over here. Who can you hang out with? Everyone over here. Who can't you hang out with? Negative 20 over 13. It's the only one that will cause an issue. Final answer using interval notation from negative infinity until negative 20 over 13, parenthesis, then union, negative 20 over 13, we start again right after it until, boom, done. If I have two factors on bottom, I might have two bad numbers, two bad kids. Both those kids shoplift. You're not allowed to hang out with either of them. All right, so I'll look at that in a second, but let's just look at this rule over here now. So that's essentially the rule. You're not allowed to divide by 0. Now we just deal with that. How do I deal with that? I just address it and block that number out. Okay? We said the other rule with square roots. What are we not allowed? Not allowed to take the? Good. You're not allowed to take the square root of a negative. So what if I have 7x minus 4 in here? Do you remember what this thing is called, this expression on the inside? Good, radicand. The radicand, I'm not allowed to take the square root of a negative. I don't want to write cannot be less than. Like, I usually would write can't equal, that's fine, but cannot be less than would be like cannot be less than. That's, a little weird looking. I don't even know what that is. So I'm not going to write can't be less than. Instead, I'm going to just point out what it can be. What do we say? If it can't be negative, it has to be positive or, right, non-negative, which means positive or equal to 0. Good. Greater than or equal to 0, and that will get us to our domain. So you set your radicand greater than or equal to 0, and then solve for x, and you get your domain. So 7x minus 4 is greater than or equal to 0. Add 4. 7x is greater than or equal to 4. Divide by 7. X is greater than or equal to 4 over 7. Visually, I would suggest the number line. All we need is one tick mark. That's 4/7. Greater than or equal. Colored in or no? Colored in. And which way do we shade? To the right. So my domain is everything that it could be. That's my domain. What's that going to be? Right. Well, no. Not x is greater than or equal to 0. We just worked it out. That's the work. This, if it was just square root of x, sure, x is greater than or equal to 0. But that's not what we're working with. We have a different expression in there. So the thing inside is greater than or equal to 0. That means x is greater than or equal to 4/7. So we're good with this? There's the answer, right? Speak to me. We're quiet. Got it? We're just writing? That's all it is. What do you have to watch out for? I would say watch out for, what if I change this problem and I did this? What changes in my answer now? Not no solution. Negative 7x. I'm just going to rewrite this. Sorry, it's a little hard to say, but negative 7x greater than or equal to 4. Divide by negative 7. X is less than or equal to negative 4/7. You have to flip when you divide by a negative. Okay? We have to flip. So here's my number line. Here is, I'm just trying to keep the colors consistent so we see the change in the work is associated with this. Negative 4 over 7, less than or equal to. So again, you still color in, but we're shading which way now? Good. So you want to watch out for that, okay? So don't miss that if that's thrown in there, okay? When you divide by a negative, not when you just divide. So divide or multiply by a negative, then you use, you flip your inequality symbol, okay? Final answer would just be then from left to right, negative infinity, comma, negative 4 over 7, still with a bracket, okay? These get more intense later on in the course, but for right now, that's all I need you guys to know. So those are just a bunch of examples. If I need a domain and I had to use set builder notation, that would probably present itself in a way like this. Here I have a graph, but my graph is not continuous pieces or segments. Make sure you read through your notes packet. We did take time to write phrases down. When is it appropriate to use interval notation? When should you use set builder notation? So in this case here, I'm not going to do an interval because I don't account for every point in between. I can't say from -5 until 5. Not every number is being used. So what numbers are being used? I would say my domain, I would use set builder. You got to use a curly bracket. Set builder notation, and again, you go in order from left to right. So from left, I have -5, -3, 1, 2, 5. -5, -3, 1, 2, and 5. Nothing was repeated, nothing really to worry about. So is this a function? Yes, because we did not fail the vertical line test. No x's were repeated. However, the range, okay, the range. Just like I showed you with the graph pictures, we could turn it sideways and still go from left to right if you don't like going bottom to top. Left to right, I have -3. I missed this one, sorry. I have 1. I have 2, and I have 4, all right? Could you do it this way? Yes. -3, 1, 2. Now, should I do 4, 4? No, you do not list more than once. You only list it one time. We're good to go. If you did a mapping diagram, we would just have 2 x's pointing at the 4, and we're good to go from there, okay? So that's using the domain from that perspective using set builder notation. If you're dealing with domain and range and you have this broken up function, this is a function, it does pass the vertical line test. But when you're finding the domain, your domain is only really asking you about the x values. The x-axis could be under it, through it, above it, whatever. If this is not accounted for, but that is, pretend like you could just sort of slide it, only vertically, you're not changing your x values, straight down and connect it like that. We'd be good to go. Now here, I happen to have, right above it, a dotted line. Is this x value where the open circle and dotted line is that x value ever included? No. Is this x value included?
Yes.
So I would go from negative infinity until that guy. I have both open circle and dotted line. Asymptote and open circle, not included. Here, I would not break those apart. I would just connect it, okay? So I will share this video along with whatever I do with period 8 on Classroom and the one I did after school with Elise and a couple other people, okay guys?